Okay, so we're gonna continue factoring tomorrow. You do have TELPAS for this class, and I'll tell you what the topic is tomorrow, or I'll tell you later. That way you can brainstorm, I guess. You're gonna have a review on Wednesday, and the test over everything that we did last week and this week is gonna be on Thursday. Just keep in mind you don't have school on Monday because it's a staff development day for staff development for me, holiday for you. So congratulations. Anyway, so factoring difference of squares. Factoring difference of squares. So let's go ahead and dissect this. That way I'm recording. Y'all took forever. I'm already started. Zip it. So what are some words that you can translate from that? What is the difference of what you see there versus what we saw last week? There's only two terms. So if you remember what we did last week, we had problems that had three terms. And if they have three terms, what are they called? Trinomials. Now I have this written on the board, but since they're not gonna be able to see it on the video, say we have x squared. I'm pretty sure I messed this one up. You don't need to write this down. I just want you to participate. What would you do in this situation? How would you factor this? What's the first, where's the first location that you look at? In front of the squared term. Now, if there is no number in front of the squared term, how would you solve that? You put it in your diamond where the last number falls to the top, middle number in the bottom, right? What if you had this example? Once again, I'm just making up numbers. I don't even know if you can factor this, but what if this is how it looked?
Kidnap.
Kidnap. What does it mean to kidnap? You multiply, you throw it to the back of the van. Whatever you get from that goes here, and then here, middle number in the bottom, you put it into your binomials, and then what? Because you kidnap. You divide by the number that you kidnapped, which is in this case, the number 6, okay? But that's when we have a trinomial. If you look at what we're gonna work with today, it's actually going to be simple. I wanna say a 2, hopefully on a scale of 1 to 5. And the way you're able to recognize what you need to do is because you have two terms with a minus sign in the middle, two terms, minus sign in the middle. And when you get the STAR test, your answer choices are going to be in the form of a binomial. So you know you need to factor. Now, one of the words that you should automatically be able to recognize is what? One, two, three. There's 4 words there. You should be able to recognize one of those words. What word is that? Difference. What does difference mean? It means to subtract. Subtract. You see this minus sign? We are subtracting. There is a difference of 2 squares. So this is our difference. Difference minus subtract, whatever you want to think of, whichever way you want to think about it. Now, when we're talking about squares, we're talking about your perfect squares, and we're going to be working with our perfect squares again, perfect squares again on Friday, okay? Perfect squares. Now, in order for you guys to get a better understanding of what a perfect square is, I'm going to draw something that you don't have to draw. I just want you to look and participate, okay? I'll come back to this in a little bit in case you didn't have time to copy that down. Let me erase that, delete. Okay, what characteristics do you know about a square? It has 4 what sides? Equal sides, meaning all sides are the exact same measurement. Exact same measurement. So here we have one box, meaning that the length, the width and the height and width are going to be what number? 1 and 1. It is a perfect square. We got one side, right? What if I expand it? Now, how many boxes high is this? 2. How many wide? 2. And 2 times 2 gives us 4 boxes. This is also a perfect square. Let's try again. Oh Lord, I thought I had my box feature. Yeah, maybe that. All right. It's not perfect, but how many boxes high? How many boxes wide? Same exact length as the height and the width. And how many, what do you get? How many boxes? 9 is also considered a perfect square. So how do you get a perfect square? When you multiply what? The same number times itself. 3 times 3 is 9. 4 times 4 is 16 is a perfect square. 5 times 5 is 25 is a perfect square. 6 times 6 is 36 is also a perfect square because you are multiplying the same number times itself. Everybody understand now where we get the word perfect square? Now, when you have the difference of squares, let me see. What you will be doing, and since this is a variable, we have to actually kind of go over this. Okay. If I take the variable x, since in algebra we use variables, if I take the variable x and I multiply it times itself, what do I get? What is x times x? X squared. Okay. But now let's go full cycle. How do you get rid of the x squared? Divide? Think about it. How do you go back to the beginning? We're trying to go full circle. We're trying to go back to the beginning. Think about if you're planting a tree or any type of plant. What is the beginning stage? You start with the seed, but what's the first thing that pops up, I guess? The what? Not a weed. The what? No, not a weed. Weed doesn't pop out of the seed. What pops out of the seed?
Oh.
The root. The root. Root is the beginning of the plant. I mean, of course, after the seed, I haven't had anybody bust out with the seed. So root is the beginning of the plant. So how do I get rid of a squared? Take the root of it. Go back to the beginning is to take the root of that squared value, of that squared number. They don't think outside the box. So a lot of people don't think outside the box. So if I take the square root, I get back to x. The square root of x squared is x. Now let's try again. X times x, x squared. How do you get rid of a squared? Take the square root. If I take the square root of x squared, I'm back to x. Let's see it with numbers because letters can always be confusing. Let's try with the number 6. All right. Let's square it. 6 times 6 is, and how do I go back to the 6? By taking the square root. And what is the square root of 36? 6. Full circle. To get rid of a perfect square, you can take the root of it. If the number is a perfect square, you could take the root of it. Okay. Now, just because I don't want to be going back and forth with the calculator, does anybody remember how to find the square root? We have worked with that symbol before.
Yep.
Where is it? Second, x squared. Now, x squared is what button? How many down? The 5th button. 1, 2, 3, 4, 5. 5th button in the first column. It's in blue. If you look at that symbol, it's in blue. It's right. It's where the x squared is. It'll give you your root symbol. Okay. So if I take the square root of 36, I get 6. What if I give you another number? Let's say try the square root of 18. What do you get? You get a decimal. 9 times 2 is 18, but not 9 times 9. 9 times 9 is your perfect square. So if you get a decimal, it's not considered a perfect square. When you do have perfect squares, and I will show you how to recognize that, but when you do have a perfect square, what you're going to do is you're going to take the square root of both values. So I'm going to take the square root of a squared, square root of b squared. Now, we just practiced this with the letter x, with the variable x. So let's practice with a different letter. What is the square root of a squared? A times a squared. What is the squared root of b squared? B times b is b squared. Get it? Get it? I was gonna say got it, and then I said. So now how to set up your binomial. If the term is in the front, you leave it in the front. If the term is in the back, leave it in the back. Ignore the minus sign. The difference part is what tells us how to do the, when to do difference of squared method, okay? So A in the front, B in the back. And here's the hardest part. One's plus, one's minus. That is your binomial. You take the square root of both terms, leave them in the same spot in your binomials, and then one is plus, one is minus, okay? Now, with difference of squares, this does involve checking for your greatest common factor. And once again, I'll show you how to recognize when you have to do that and when you don't. Half of the problems that we do today, you will have to check for your greatest common factor, which is the very, very first lesson that we did right before the diamond problems, okay? Everybody ready? All right. So, example number 1. First step is to always check to see if you need to take the greatest common factor. You will know if you need to or not whenever you take the square root of the number. You cannot type x squared in your calculator. So take the square root of 81. Correct. If I take the square root, second square root, 81, we get a perfect square. We get a perfect whole number. So that means I can continue. I don't have to check for the greatest common factor, okay? So I'm going to take the square root of both terms. Oops, my pen. Once again, ignore the sign. You know that you need to do this method when you have two terms with the minus sign in the middle. That's what that's telling you to do. Now, what is the square root of 81? 9. You can do that in the calculator. You cannot do x squared in the calculator, but we did just discuss it. What is the square root of x squared? X. And what is the square root of 36? 6. Okay. Once you find the square root of both of those, you are now able to set up your two binomials with what term in the front? 9x. 9x is currently in the front, so 9x is going to stay in the front. What term in the back? 6. And the last step, hardest step, is to remember that one is what? And one is plus minus, plus minus. And yes, you can have minus plus in that order. It doesn't matter. Now, I did have somebody ask me in first period, which I actually did think it was a good question. And we are gonna show it, we're gonna write it. They said, what happened to the middle term? Or why are we using plus minus specifically? So we're going to look into that. Remember, when the topic that we studied before this was for me to give you the two binomials and you had to do what with them? Why did we draw the box? Because we were doing what? Not add. We were multiplying. To fill in the box, we were multiplying our binomials. We wrote one binomial down the side of the other across the top. I want you to write this down. I want you to be able to compare how this ties into the last topic that we worked on, 9x minus 6. Now we multiply those binomials. We're going to flip the paper over and we're going to write this down and we're going to draw the box and multiply. 9x times 9x, it gives us what? Okay, now 9x times negative 6 is negative 54x. 9x times a positive 6 is, and then the last, negative 6 times 6. All right, now after we're done multiplying, what do we always do? Combine. And which ones do we combine? The diagonal. And how do we combine? By adding. But what happens when you add negative 54 plus 54? They cancel out. These two cancel out. So by making one of my binomials positive and the other one negative, what it's doing is it's eliminating that middle term, because now when we put together what's left, 81x squared minus 36, we've gone full circle. Everybody compare those. You see it? So a few weeks ago, we were working on multiplying. We started with the binomials and we multiplied them to get us this binomial or a trinomial in some cases. Now we're working with these binomials and trinomials and breaking them back apart. Got it? So you can work backwards if on the day of the test, if that's what you remember. If all you remember to do is foil and box, it's a lot more work, but it can be done. All right, so questions on the STAR test will be worded similar. Write an expression equivalent to. I do not like that though. Okay, so write an expression equivalent to. You know that you're going to use difference of squares because why? Two things. What's up? Not because of the variables. No. There's a minus sign in between how many terms? Two. Two terms, minus sign. That means I get to try to do difference of squares. Now, what's the first step in difference of squares? To take the square root. But what happens if you take the square root of 32? You get a decimal. So if I get a decimal, does that mean it's a perfect square? No. If it's not a perfect square, what does step one on the front side say? Find the greatest common factor. Greatest common factor. And for those of you that forgot the steps to find the greatest common factor, we do all of these steps backwards. You start with the factor, find the ones that you have in common, and then find the greatest common factor. Okay, so first we have to find the factors. Now there's two things that we have to check. We have to check to see if both terms have what and what before we find the greatest common factor. There's two steps. The same variable. Now look at those two. Can they have a common factor if they do not have a common variable? No, because what does common mean? Same. If you have a different letter, there's no same letter. There's no common factor. You don't have a letter in common. But what do they have in common? They both have what? What? Not exponents. Coefficient. They both have numbers in front of the variables. We have coefficients. So let's find the greatest common factor. See if any light bulbs go off, because I see that a lot of us have forgotten. You ignore the sign in the middle. That one always comes straight down. This is what we studied in the beginning of last week and the week before when it iced over. How do we find the factors of 32 if I don't know them? And what do you do in y equals? Number divided by x. So go to y equals, and I'm going to put my 32 divided by x, and then where do I go? Is it necessary for this one to have x plus y1? No, the x plus y1 helps us with the diamonds, and we're not looking at diamonds right now. So which one of these are fair game? Only the whole numbers. Okay, so 1 times 32, then what? And then what? 4 times 8, is that it? Okay, now for 72, 1 times, 2 times, 3 times 24, 4 times 18. Because when we get to 9 times 8, 9 times 8 is the same exact number or same exact factor as 8 times 9. So we're done. Now we have found the factors. Now we got to find C. What is C? Common. Now we got to find the ones they have in common. We always want to start with the 1. They're always going to have the 1 in common. Anything else? They have the 2 in common. Anything else? And then also the 8. Now, when I was grading your assignments, a lot of you guys would pick the 4. But what does the G in GCF stand for? Greatest. It doesn't help to only find a common factor. We're not looking for CF. We're looking for the GCF, greatest common factor. You can't just pick any number. You have to follow all the way through and get the biggest number. And in this case, the greatest number is 8. So we circle it. And why do we circle it? Because that is going to be located where? In the front of what? The parentheses. So we're taking an 8 out. We're dividing. We're undistributing an 8. And when I did that, let's take a look. What was left inside? I circled the 8, but what did I leave inside? 4. X to the 6, because I didn't do anything with my variables. Sign always comes straight down. I circled the 8 for the second term, and what did I leave? 9, y to the 4th. Now, if you do the greatest common factor correctly, what's left inside should be a perfect square. Can I take the square root of 4 and get a whole number? Yes, so let's go ahead and take the square root of both terms. Square root of 4 is what? 2. For x to the power of 6, you kind of have to think about it a little bit before I tell you what the rule is. What do you multiply times itself to get x to the power of 6?
1.
X what? You can't, x squared times x squared, what do you do with the exponent? You add them, so 2 plus 2 is 4. You changed your answer to 3, so x cubed times x cubed, what do you do with the exponent? Add them, so 3 plus 3 is, so x cubed. What's the square root of 9? 3. 3 times 3 is 9, and now the square root of y to the 4th? At y squared. Y squared times y squared, 2 plus 2 is 4. X cubed times x cubed, 3 plus 3 is 6. You see it? So that's the rule. With exponents, you're always going to take half of all exponents. You're going to be taking half of all the exponents. Somebody said you subtract 3, but I cannot apply that rule to every single one of them. I can subtract 3 to get my x cubed, but if I subtract 3 here, I don't end up with y squared. You take half of all your exponents. Everybody got that?
Yeah.
All right, now let's put our final answer together. You bring down your greatest common factor, which is 8. And now we can create our binomials. What are we going to have at the front of both of those binomials?
2.
2 what? Okay. And what will we have in the back? And what is the last step? What signs? Plus minus. There's my final answer there. So if you have a greatest common factor, if you get a decimal in the very beginning, yes, there's more steps. And we will have more examples of that just so we go back over something like that. Ready? All right. Write an expression equivalent to, how do you know this is difference of squares? You see how many? 2 terms with what in the middle? Minus sign. Okay, so what's the first step? To try to take the square root. And if I take the square root of 4, does it give me a perfect square? Perfect number? Perfect number 2. So the square root of 4 is 2. Square root of x squared is x. The square root of 25 is, and the square root of y squared? Y. Y times y, y squared. X times x, x squared. Everybody see it? Yes? Head nods? Okay. Now we can put it in our parentheses and create 2. And what's going to be in the front of the binomial? 2x, and in the back? 5y. Last step, plus and minus. So once again, if you do not have a greatest common factor, easy peasy. Easy peasy. Got it? All right. Head up. All right, same wording, write an expression equivalent to. How do I know I'm trying difference of squares? Two terms with what in the middle? Minus sign. But what happens if I try to take the square root of 20? What do I get? Decimal. So if there's a decimal, there must be a greatest common factor. Then there must be a GCF. Now, you do these steps backwards. First, you find the factor, find the ones that you have in common, then you find the greatest one. Now, both terms have what? Coefficients. So I'm gonna make a chart for my coefficients, 20 and 125. This time, both terms also have what? Variable, the same variable. So x cubed with x. All right. First step, find the factors. We start from the back, work our way forward. Find the factors. What are the factors of 20? 1 times 20, 2 times 10, 4 times 5. Now, if we multiply 5 times 4, that makes it the same. And we stop there. What about 125? 1 times? And? Yep. All right, now we found the factors. Now we got to find the ones they have in common. All right, we know for sure the one will always be in common. What else? All right, now the G in GCF stands for? So the greatest common factor is which one? 5. Circle the 5, underline the other one. Circle the 5, underline the other one. Okay, now let's find the greatest common factor with our variables. X cubed means we're multiplying X how many times? 1, 2, 3, and then 1 for the other side. How do we know, or what do we do to figure out how many X's to take away? You group them. How many groups can I make? Only one group. Now, a common mistake that a lot of you are making after I graded these assignments is that I notice you're circling 2 X's, so you're using it as X squared. No, it goes by the amount of groups. These 2 X's count as 1. So unless you have 2 groups, that's X squared. 3 groups is X cubed, but we don't. We only have 1 group. So what will be on the outside of my parentheses here? 5X. Okay. Let's see what we have left over so we can do difference of squares. I circled the 5. What did I leave? 4X squared, because notice, everybody see these 2 uncircled X's? That makes it X squared. Bring the sign down, head up, circle the 5, and what do we leave? 25. Okay. Now we didn't leave any uncircled X's, so we stopped there. But now that I have my greatest common factor, I'm ready to do what with my other 2 terms? Take the square root of them. Square root of 4 is square root of X squared. Square root of 25. 5 times 5 is 25. Now we're ready to put our answer together. What do I do with this 5X here? Just bring it down. You always just bring your greatest common factor down. So 5X. And now I'm going to split my binomial apart into 2 binomials to my factors. What's going to go in the front of both of those? And what about in the back? And in the middle? Plus minus. Once again, yes, it can be minus plus. That part does not matter. As long as one's plus, one's negative. Got it? Questions? All right. Now for a couple easy ones and one more greatest common factor style. Ready? Read the question. What are they asking us for? Are they asking us for both factors?
No,
Just one. Remember, if I ask you for a piece of paper, I'm asking you for one piece of paper. So if you look at your answer choices, don't get confused just because you only see one binomial. You're still going to get 2 binomials as your answer, but they're only asking you to match it up to one of them. Now, the first step, when you notice that you have 2 terms with the minus sign in the middle, is to try to take the, and if you take the square root of 9, do you get a perfect number? Yes, and that perfect number is? And the square root of X squared is? The square root of 16? Now we're ready to put it into or create our binomials. What's going to be in the front? And in the back, 4. Last step,
plus and minus.
plus and minus. So your answer choices A, B, C, D is only going to match up to one of those two. Questions?
Wait, no.
Yes. What's up? Okay, so let's say we start with X, right? If I take the square root, we said the square root of X squared is X, right? So if I take X, what do I have to do to make it squared? So X times X is X squared. If I take the root of X squared, that gives me X. The root is the beginning. What did you multiply to begin with to get to X squared? Get it? Okay. Another one, example 6, once again, which one is a factor? We're only looking for one of them. We still have to get both of them to match it up to one of them. What's the first step? You see two terms with a minus sign, you take the, all right. And the square root of 25? 5, it gives us a perfect number, so we don't have to worry about greatest common factor, square root of n squared. And now the square root of 81, perfect squares when it gives you a whole number. Once you're done taking the square root of both, you put it into your and create two binomials. Now what's going to be in the front and in the back? And what do you put in the middle? Plus minus, plus minus. Hopefully those that are actually perfect squares are simple enough. Y'all ready? Same thing. What do you notice? Two things. What two things do you notice? No. What's the first? No, what's the first thing you check? Okay, first thing we see is a minus sign in between what? 2 terms instead of 3 terms. Last week we were working with trinomials. Right now we're working with binomials. 2 terms, minus sign in the middle. What are we going to do? Take the square root. What happens if you take the square root of 8? It gives you a decimal. If it gives you a decimal, that means that we have to look for the greatest common factor. Now, what things do they have in common? Both of those terms have what? Correct. Do they both have the same variable? No, one of them does not even have a variable. So we're only looking for the greatest common factor with the numbers. What are the factors of 8?
2 times 8, 2 times 4.
And what about 18?
1 times 18, 2 times 9, 2 times 6.
And if we scroll down a little bit further on the calculator, 6 times 3 is the same, so we stop. We found the factors, now we got to find the ones they have in. All right, which ones do we have in common? Is that it? And now G, greatest of all of these is circle the 2, underline the 4, circle the 2, underline the 9. So what goes on the outside of my parentheses? 2. Let's see what we have left over. I circled the 2 and I left what? Did I leave 4G? No, it didn't have a variable to begin with. So no 4G, just bring that sign straight down. I circled the 2 for the second term and I left a 9G squared. Now, if you take the greatest common factor out correctly, what should be left behind? Perfect squares. Perfect squares. Now, if I know it's a perfect square, what do? Take the square root of both terms. The square root of 4 is 2. The square root of 9, square root of G squared? G. All right, what do I do with that 2 in the very front? Bring it down. And I create 2 binomials. Now, some people might try to do this, but even though we're typically used to seeing the variable in the front of our parentheses, notice it is located in the back of our terms, in the back of our binomial. So it should stay in the back. What's going to go in the front? 2 and 2 in the back. And the last step, plus and minus. Okay, now I am going to hand you your homework. The whole front side is what we did last week, okay? And the back side is your perfect squares.